over to you.
All right. Am I live? Mic check. Everybody can hear me? All right, cool, awesome. Hi, I am Alan C. Smith. I'm limited on time, so I won't do my normal lengthy introduction. I will just say that I've been doing this for over 30 years. Makes me one of the old guys in the room. And I want to talk about decoupling in practice and basically how to save your sanity writing code. Tell me, please, who here has suffered from long project load times? You know, you go to start work and you fire up your project, you go get yourself a cup of coffee, talk to a coworker, maybe read a short Russian novel, you come back and maybe your project is loaded. Okay, yeah, every single one of us, right? Okay, long build times? I don't mean an hour. I was told by R&D that an hour or so is not an unreasonable build time. I'm talking 3, 4, right? Okay, we've all got a few, saw some of those hands. How many of you, as you have been doing those long builds, have had an unexplained failure? Yeah, and I'm not talking broken VI, I'm not talking missing dependency, I'm not talking something that you can kind of, oh wait, yeah, I kind of see that. I'm talking just, no, screw you, you don't get to build your project today. Okay, yeah, lots of hands on that. How many, does this happen? This happened to me. This is, I have one of my current live projects, legacy project that I got from a prior developer. Software does great, does everything they're supposed to do, looks real pretty. I got brought in because the original developer was not available and needed to do some work, and heavy class-based system. This also has long load times. The builds all work, fortunately. But I says, I gotta do some work, so I'm gonna grab one of the base classes, this channel class, and I'm gonna pull it into a project so I can work with it all by itself. And I loaded the entire project. So this presentation was inspired by my need to rant about this, and some obvious things that were done that were like, why did you do that? I can't claim I'm going to magically solve your problems with long load times and long build times and stuff, but I am going to talk about things that we can do to make it better, and specifically some dumb things that we do to make it worse, okay? What we're dealing with, of course, is loading our applications in LabVIEW. LabVIEW loads information out of VIs in different ways depending on what it's doing, depending on whether we're pulling VIs into memory to work with them directly, or we're loading a project, or yes, doing a build. They actually do something under the hood. They all do something a little bit different. And I'm not going to go into that. That's not my focus. We're just aware that we have this going on. If we're loading VIs, you know, you open up Windows Explorer or the equivalent on your operating system, and you grab your top-level VI and, wait for the project to load. What's going on is you're loading your top-level VI, you're loading all of its dependencies. That includes any sub-VIs it has, and their sub-VIs, and so on, that hierarchy. Plus, if it's in a library, you're loading the owning library or the class that it's in, and of course, if anything that they link to gets pulled in as well. If you're loading a class, you do load all member VIs, whether you're using them all or not. Interestingly, and this is something that I did not know until quite recently, and I think there's a lot of misinformation about it, loading a library does not necessarily load any of its members. I don't know if that was always true or if that was a change they made at some point, but it supposedly doesn't. Project's a little different. We load different information when we're loading the project, and that's, by the way, why you see you'll load your project and it takes a while, then you'll load the top-level VI and it takes a while again. We're loading different information. With a project, we're loading information from disk about dependencies. We're loading any members that can define a tree of dependencies. So that's going to be our libraries, including any libraries nested in our libraries. That's going to be our classes. That's going to be our VIs and their sub-VIs. But again, not the VIs themselves, just information about how they link. That should be fast. The fact that it's not is kind of a mystery to me. I've tried to talk to R&D people, and we haven't quite drilled down to what's going on there. But a large part of it is that we are actually populating that dependency list. Okay, that's a part of what we have to do. I think it just goes down the first tier, but we do have to populate it. And LabVIEW's got to step through all of these connections to figure out what has to be loaded into that. And apparently loading the dependency item takes a little while too. Anyway, that's what we're doing. By the way, footnote, if you don't already know this, little gem, that is probably your best way to figure out what your dependencies actually are, is to let LabVIEW go do it. Pull the item into a blank project, see what shows up in dependencies. Let LabVIEW do it for you. So, for those of you who've been doing this a while, pre-libraries, pre-classes, when it was just VIs, we didn't have some of these problems. Where did we start getting into having our challenges? And that gets down to having long dependency chains. So, I have a VI. Say it's the top level VI, it's the user interface for my application, and I load it. It happens to be a member of a class. Well, what did I just say? We load a member of a class, we load the class. Well, if that class is sitting in a library, we're going to load that library as well. So far, so good, but chances are, if I have a library of things, they probably talk to each other. And so we're going to load all of those things that we're connected to within our library. Again, so far, so good. But then if one of my classes calls a member VI from another class, we're going to load that class, which is going to load its library, which is going to load anything in its library that it talks to, which is going to load anything in other libraries that it talks to, and so on, and so on, and so on. So you can get these long dependency chains. To a certain extent, this is inevitable. There are things we can do to break that up. I have another talk about when we're doing this and it's intentional, there are ways to break that up. I have another presentation I'm going to mention that goes into techniques for solving that. But where we really get in trouble, the thing that really just shivs us in the night, is when we have a cyclic dependency. So I have my two libraries, and I have, my class in one library calls a method from a class in another library, and I've got that long dependency chain situation. Okay, we're fine. But then I have something in that library calls back and connects to my original library. This is called a cyclic dependency, because I can start with any one of my objects, and I can follow the arrows around, and I can get back to where I started. This is bad. This is really bad. This is the bad thing I did with Actor Framework Library and AFDebug Library that I'm fixing in the open source project. Don't do this. Avoid this wherever possible. This is bad enough. Just those two little libraries have caused us all kinds of grief over the last decade. But if you compound the problem with long dependency chains and multiple cycles, that's where we really get into trouble. Okay, that's where your load times blow up exponentially. That's where your build times blow up exponentially, and enough cycles, and it doesn't take very many, and yes, your build will fail. Because LabVIEW just can't resolve it all. There's just too much going on. So we have to design for this. We have to take this into account with what we're doing. This is not sexy. This is not something you can come to a room full of your peers at a GDevCon and say, look, I decoupled my application, and people are going to think it's really awesome. This is not going to check any sort of box with your customers. They don't know, they don't care, right? They care about that, like my customer with this other project, they had a great application that solved their problem and looked really good, so they were happy. Under the hood, we had a mess. But it is something we as developers have to understand and have to take care of, have to account for, make the old girl work for us the way we need it to. And that's okay, because that is why we have software architecture. We need to account for that in our architectures. How do we build our systems? The purpose of architecture is to make it easy for us to do our jobs, to write the software, to deploy the software, to maintain it. If I pull a base class into a new project and I load the entire project, that is the antithesis of easy to work with. So let's not do that. I go into detail on the techniques because, like I said, you're going to wind up these long chains, and they're to a certain extent unavoidable. There are things you can do to manage it. I go into details on that on a presentation from GDevCon NA number 1 back in 2021. You can go find that video. I'd encourage you to do that. I'm not going to go into that today. As I said, I want to bring up some very specific places. It's one thing if I couple two things where I know I want them to work together and then think about how do I take them apart. And it's another when I couple those things because I'm just not paying attention. And those are the ones I want to bring up today that you need to be aware of. And I'm going to start with cycles in VIs. Yes, you can build a cycle within your VI hierarchy. No classes, no libraries, just your VIs. Anybody know how? Recursion, right? I can write a VI that can call itself. I mark it as shared clone reentrant, and I can do that. I just did that the other day for a serialization technique. It's like, great, awesome. Recursion's great, solves some awesome problems for us, makes for very clean code in terms of being able to read it and maintain it, which is great, checks a bunch of architecture boxes. But if your VI hierarchy is large enough, you can actually have deep recursion, where a recursive VI calls a VI, calls a VI, calls a VI, calls back, and you can conceivably build in several of those. Just be aware of that, okay? I think that it's happened in a few corner cases. People will do that. Sometimes they get in trouble. Just be aware of when you're building these recursions, and you'll be fine. Where it gets exciting, and where I think a lot of people routinely run into trouble, is when they start with their libraries. And here's a fun one that I think a lot of us do at least once. I know I have. And that is putting a type def in a library or a class. Now, we like type defs, right? They make building our software easy, maintaining our software easy. So imagine a situation, I'm going to talk about a class here, but it applies to libraries as well. Let's imagine that I have a class, and my class does some work, and my class contains, the kind of work that my class does is it has some sort of state information, and every now and again it'll change what it does based on that state, and I'm representing that state with an enum. We've all done that, right? That's actually the state machine. And enum's incredibly useful. Like, well, it's an enum. What do they teach you in Core 1? It's like literally, it's like 2 slides after I tell you about type defs, I tell you about enums, I'm telling you about type defs. So we do that. So we make that type def, and then we stick that type def in our private data, because that's where it's supposed to go. And there it is in the class. Great. We're doing good. Until you do that. Until I make an accessor to let somebody outside of my class write my type def into me. Now, why is that? This is where it goes horribly wrong. Okay, why is that? Well, something's calling my class API, and that's what I've done. I've made that type def a part of the class API. So my caller, and in this case I've just got a queued message handler, my caller is calling my class, and you can see that my calling module is calling my type def, and we're still okay because I have to call everything else, I have to call methods of the class, we're fine, except that that queued message handler is getting a message from somewhere else. That other module has to have access to the enum, to the type def, and now I have taken 2 modules that have nothing to do with each other, should not be connected in any way, but they're connected by this enum, by this other class. That is an unintentional connection that can lead to accidentally writing a cycle, just because we're not aware that we've done it. The answer to this one, really obvious, but we don't think to do it necessarily, is to just take the enum out of the class, right? Take the type def out of the class. It can be in another library if you want, because remember, putting something in a library doesn't automatically load it. They can be naked, just on disk, or in a folder in your project. Just take them out of the class, if they're going to be public. If you don't ever write that accessor, it can be private to the class, and it's fine. So that's one really easy thing to avoid. Here's another one. Nesting our libraries. And this is from a real, when I was at NI, a support request that I had. My project takes 20 minutes to load. This guy had no classes. It's all VIs. So why does this take 20 minutes to load? I get his project. He's able to share the whole thing. I open it up. Yeah, it was 20 minutes. It was go talk to a coworker while it loaded up. And then when I finally get there, I get the project, and they open it up, and at the top level, I have a library. Okay. Open the library. Bunch of nested libraries. Okay. And in his case, ironically enough, it wasn't a VI, it was a type def that was sitting right there. Okay, just a couple libraries, that's not so bad. Except that every single one of those libraries had nested libraries, which had nested libraries and had VIs in them. And I disassembled that top level library, and the load time went from 20 minutes to 2. So there are a few exceptions. I will mention one later, where nesting a library inside of a library might make sense. As a starting position, this is to be avoided, and especially at this kind of depth, right? Really, in the use cases I've talked about, there's like, you might want to go a library and you're kind of done there. If you're going to this kind of depth, and this is, I only saw that the one time, but I bring it up because it was just really pretty awkward. You'll also get really bizarre qualified names if you do that. So if you're talking about doing this to namespace, you're going to get some really weird namespacing. Neither here nor there. Okay, so that's libraries. Let's talk about some really obvious things to avoid with classes, shall we? I love me some classes. Talk about public helper methods. So I have a class A that shouldn't be dependent on anything else. I pull it into my blank project to see what it depends on. Oh, it depends on class C. For no obvious reason, it's not called, class C is not called on any front panel, it's not called in any block diagram. Okay, I'm not passing the class through, I'm not passing C through A, what's going on? So, I right click on class C and I find out what its callers are, and it points me to this calculation VI in class A. Okay, so I go and look in class A. I'm still not calling the class itself, but I am calling one of its methods, a method that doesn't take a class input. It's this little math VI, which happens to be down here in class C. It's this transform that it does. Okay. And I go poking around in that, and I find out that it is just it's just a little math VI. The developer who wrote class C did some math, thought the math was useful to stick in the VI, so they did that. Person writing class A came along and said, I need that math. So he just grabbed the VI, and now he's coupled his two classes together. Again, the kind of accidental, unintentional thing that can get us in trouble without being aware. Obvious answer, again, oftentimes when we're trying to solve these dependencies, is we just pull the offending item out and stick it into a different library, much like you did with the type def, okay? In this case, I'm building up a little math library with the transform. Both A and C call on this transform, but hopefully it doesn't link to other things. And so I've cleaned up some of my dependencies that way. Now, there are times when our classes do, in fact, use other classes, and we pass the class through, class B through, or A through B in this instance. Okay, this seems legit, right? Class B needs class A for something. But let's take a look. Class B needs class A because it needs to get a piece of data out of class A, and that's it. Well, this is also one that's kind of, why would you do that? We've made an accessor on class A to get the piece of data. We have declared to the world that we can get that piece of data out of class A. So why do we have to pull it into class B? That's kind of a dumb thing to do. All you got to do is make the calling code responsible for that exchange, and we've decoupled A from B. So another really easy win. That's what this presentation is about, easy wins. Now, there are times, obviously, when we do need to have class B operate on class A. We do actually want to pass it through. When the indicators for that, we expect A to change because B did something to it, right? Then we do need to pass it through. Or A is providing an actual important service to B in terms of an operation that maybe requires private data of B as well as private data of A. These are legit use cases. If you're not doing these sorts of things, if it's just data, let the calling code handle it. Another one that I've seen a few times and that I will confess to having done myself. In my example here, I have a family of classes. They are phonetic letters, radio alphabet, Alpha, Bravo, Charlie, Delta, et cetera, Whiskey, Tango, Foxtrot. And they all do things in common, so they have a common parent class called phonetic letter, and then the specific things that the letters do, right? And maybe what I want to do is I want to turn a text, a string into an array of these phonetic letter objects. And so I have a picker, right? I need to be able to, what's my letter? Go look up the appropriate thing, right? And that's what we do. That's what we have to do. And we're great until we put the picker inside a phonetic letter. And that is terrible because now all I have done is I have linked the parent. I've made the parent dependent on its children. This is go back to your desk and rewrite your code and think about what you've done, because we're going to have a conversation, because that led to this. Multiple times in the project, every single one of my classes that had children that had to generate what the child was did this. And I'm in the process of slowly over time decoupling that. Again, pull the offender out of the library. Just put the picker somewhere else. This is the beginnings of factory pattern, by the way, because of course I can put pick letter in a class and do whatever I need to do. So there's some obvious things for decoupling your classes. These are mistakes that I see over and over again. I've made them. I won't ask for a show of hands because I know some of you have done at least one or I got a hand in the back. Some brave soul is volunteering for having done these things. I think it's just a part of the learning process. Please learn from my pain. It's always less painful to learn from somebody else's mistakes. Now, we can get coupling in our frameworks. That's kind of the highest level. I'm going up the hierarchy of complexity in our artifacts. And I'm going to mention two. DQMH Actor Framework are two largest, most commonly used frameworks in LabVIEW. I will start with Actor Framework because I have the most experience with it. Here's a couple of actors. I have a device. I have a UI. The UI is the UI for the device. I want them to exchange data back and forth. I have two nice modules. At the moment, they're decoupled. Okay, they're sitting in libraries. There's classes inside libraries. So this is the setup for our long chains if we're not careful, right? So how do these get coupled? Well, device wants to update the UI, so it calls a message of the UI actor, and that's a static link, okay? And so device now depends on UI, and of course I can absolutely build a cycle by going the other way and having, the UI be able to change the set point on the device. Now I have coupled my two classes. This is one of those use cases. So this may, under certain circumstances, be desirable. You may have two actors that really, you need to have the separate message handling, but they are so coupled together in the way they work conceptually that just having these direct links are okay. That is an instance where putting these two libraries inside of a common library is fine, especially and primarily if what you want to do is manage access scope on the messages themselves. So if I have two actors that are so tightly coupled that they need to go together, I likely have messages going between them that I don't want anybody else to call. At that point, if you put them into a common library, I can access scope those messages to make them private to the library and no one else can call them. That's a reason, one of the short list where you might want to nest libraries. But again, not terribly deep, and it really is because device is a library and the display is a library. Okay? The way we decouple actors, assuming we don't want to do this, which is going to be most of your use cases, is, of course, interfaces or abstract parent classes, but we'll go with interfaces because it's 2024. If I make an interface to the actor where the interface has all the messages, and then the actor inherits from the interface, then I can go ahead and draw connections. I can call messages from the interfaces, and I know I do not have a cycle here. There is no way you can follow an arrow around and get back to where you started, okay? And that's what you want in most cases. DQMH has a similar potential situation. I'm not a deep expert on DQMH. I've used it a little bit. But one of the ways that you can, the way you can get a cycle is, if module 1 and module 2 are exchanging messages, and they both do those messages as requests, now I have a cycle, because in order to send a request, I am calling a VI from the other module's library. Okay, the way to resolve that is the communication is still two-way, but we can make the VI calls, which is what we're talking about here, the thing we have to manage. We can make that be one-way by having one module send requests and register for broadcast, because that has all of the dependency flows, all the artifact dependencies flow in the correct direction. So that is basically time. I just have a couple of minutes to wrap up. The big lesson, the big thing to take away from the thing you want to pay attention to is not creating any cyclic dependencies. There are ways, if you're doing something deeply structurally, architecturally, that you need to do, there are ways to manage that, usually involving interfaces. Use those. Restructure your libraries as needed, move VIs around as needed, do whatever you need to do to break those cyclic dependencies, because they will kill you. Use recursion appropriately. Your type defs are foundational. They are the data types of your system. They should not be, unless it is truly private to the class and going to stay that way, it should just be loose. Maybe in a library of type defs, but loose is just fine. With a few exceptions, avoid nested libraries. Your helper functions are also foundational. So you may have a library of math functions that you build, for example. Simple data exchanges are brokered by the caller. If you can make it so the two classes don't have to know about each other to get your work done, better. Parents do not call children ever. And do what you can to decouple your high-level modules. That's going to be interface calls and so on and so forth. And that's what I got. Here's how to find me. Tell me you saw my presentation here, and I will link to you on LinkedIn. And I have 1 minute and 45 seconds for questions.
Andrei Zagorodny, Sweden. I have such a question. Tools to identify cyclic dependencies.
Yeah.
Now I use actually only, as you said, create new project, put a class or group of classes and see dependencies. But it's horrible work on big projects. Are there any tools helping to identify cyclic dependencies?
Sadly, no. Sadly, there are not. I mean,
I start to cry.
So, I'm sorry?
I start to cry.
Yeah, please do. John McBee had a tool that has been maintained since 2016. Does still work? Okay, there you go. Yeah, so what's his website? I'm drawing a blank on it because I'm standing here under lights.
Okay, I come later and touch.
The LabVIEW Craftsman, yeah. So if you look on his website, it hasn't been maintained in a while. But it's probably one of those things that if you want to go talk to him and like do some work on that, he'd probably really love you for it.
Which library is depending? It's not showing which type def is creating the dependency.
Okay, but it shows libraries.
Yeah,
so it's a start. It's a start.
The difficulty is the.
Thank you.
Yeah, but again, it's not showing you which part of the code you need to modify to remove the dependency. That's the difficult part, I think.
And one small addition to your list of dependency problems. I had a very big problem with long time loading particular classes when I had separately not class belonging type definitions, but type definitions having nested type clusters. So using them in different classes was really destroying the project.
Yeah, a nested type def is just going to make that worse.
I had it was requirements from rules.
Well, and we nest our type defs, right? But just again, got to be aware because that'll bite you and not even realize it.
Thank you.
On the tool, just
you're live.
I'm live. Probably there could be a new tool using the graph library made by Cyril Gambini. This is something that could be used to parse all the project and find all the nodes. And probably there is something. It's an open source project.
Somebody need a side project? Is somebody in this room bored and not like totally maxed out on their work hours? But I mean, I have a backlog of side projects I want to work on. I would take that on, except my list is already long. But if there's somebody else, that would be fabulous. Because it's definitely a place where we could use more tools.
Well, I realize we're short on time, but philosophically, in the scenarios where you pull out a mutual dependency that's common to classes, one common challenge people run into is, okay, then if you want to build those atomically, in other words, class A and class B both share this other VI as a common thing, but you want to build them as and maintain them as separate projects. And then there becomes a philosophical challenge around how do you manage that as a common dependency?
Yeah.
Like, and I'm curious if you have any comments on best practices. Do you?
If they're, I mean, that's going to be you're going to play that by ear, right? Yeah.
But do you build it into the deployed version of those independent components, or do you have a third thing that you're then managing and building separately? That's a common dependency of them.
Yeah, you're going to wind up with You wind up with proliferating little
Right.
packages with their own development timelines, which, and then at some point you step back and you go, maintaining all of these packages is too much like work. And so you start to pull it back.
No.
Then you need tools to maintain.
Yeah.
Yeah.
You need tools, what starts happening is the lower level packages. If you really architect things right, you never touch them again
Oh, yeah.
because they were foundational and you don't touch them again, and they're built either into VIPM packages or PPLs. And actually, that's a good way to make sure that you don't create these circular dependencies, because if you're calling something that's built in, that's already built, you won't be able to go and insert the circular dependency. This is for all of you, the Dimitri, where's Dimitri on the solid principle, the open for extension, but
Yeah.
close for
Well,
that thing.
The first package principle, though, the first package principle is basically how many packages are you willing to maintain in version, and that is a factor.
Yeah, no, but what I'm saying is, if you're building and calling these things and these are foundational, they should not be changing that often. If they're changing that often, it's a smell. It's an architecture smell.
Yeah, and I would add that access scope is your friend. You mentioned it a little bit, but when, especially for type def, whenever I put a type def in a class, I make it private.
Yep.
If
Yep,
I
that's
need
exactly what you
it
do.
later, at least there is a flag, and it's not only true for type defs.
Yeah,
but
that's absolutely
use
right.
access scope the most restrictively as possible at first, and then there is a flag for you to change things. And
If your type def is in a class, which is fine, if it's not called outside the class, it should be private.
Hello. Thank you very much for the tips. Super useful. Is there a technical reason why LabVIEW takes longer to load and process cyclical paths and cyclical dependencies than linear dependencies? If, say, a cyclical dependency has 5 steps to be traversed, why does it take longer than traversing 5 steps in a linear way? And is that something that the LabVIEW compiler could do better, perhaps in the next few
gets
versions?
into stuff under the hood that I would refer back to LabVIEW R&D people that I don't thoroughly understand. I am given to understand that cyclic dependencies are often not permitted in other programming languages because they're just a thorny problem for the compiler. Why I would refer to somebody who's an expert on how the compiler works. But it's just I suspect that it's number of paths through your dependency tree that you can have, and they just grow, in an uncontrolled fashion. I suspect, but again, I'm not a compiler expert, so I can't tell you why. I would refer to, in the case of LabVIEW, go talk to the R&D guys, but I think it's a generally hard problem.
That's a very good question. Do you have a response? Or that's for later.
We were chatting and I didn't hear the question, I have to confess. What was the question?
Let's follow that up.
Okay.
Hey, anything else, hit me on Discord. All right, thanks, guys.
Thank you very much.